I want to do a couple of examples from the homework of constructing a confidence interval for a population proportion. In this example, they say there's 441 green peas, 166 yellow peas in a sample. Construct a 95 confidence interval to estimate the percentage of yellow peas. On the calculator, I'm going to go to Stat, Tests, and I'm going to arrow down to 1 prop z int. I guess it's on the next page. There it is, letter A, 1 prop z int, enter. And the x and the n are asking you for the numbers of, it was asking for the proportion of which one? The green peas or the yellow peas? I forgot. The proportion of the yellow peas. Okay, so the x is the number of yellow peas, and the n is the total number of peas. Now, it was 166 peas, and here you have to be careful because the sample is 166 plus 441. I think that you can do that right here, 166 plus the 441 for the green peas. So that's the sample size. And then the sea level, let's see if it likes that. Okay, it did the calculation for us. The confidence level is given in the question. That is the 95%, which I'm going to enter as 0.95, which is there. And when I highlight calculate and go enter, it gives me, this is the confidence interval from 0.23802. 0.23802 is the lower bound, and the upper bound is 0.30894. Let's see, the p hat here, that is the sample proportion. That's the that's the proportion of yellow peas in this particular sample. The n is the sample size. So when I go back to the homework question, let's see, what did we get? So this is the lower bound. It says 3 decimal places. So to 3 decimal places, 0.238, and to 3 decimal places, 0.309 when I round that upper one off. Let's check. Fantastic. Okay, and then let's see, given the percentage is not 25%, do these results contradict expectations? Well, no, because 25% is still inside the confidence interval, so the true population proportion could very well be equal to 25%. Good job. Okay, let's do one more because there's one little variation going on here. A drug is used to prevent blood clots among 4126. 190 had a sample, so it's 190 of 4126, and this time they want a 99% confidence interval. Now here's the thing, in this one, they gave you the sample size, so that's going to be the n on the calculator. You don't have to add these two numbers to get the sample sizes. In the previous question, you have to read the question carefully. So for this one, I'm going to go to the calculator. Again, I'm going to go to Stat, Tests, and I'm going to arrow down to 1 prop z int. And this time the x is 190, and they gave us the sample size, which was 4126. 4126. This time they want a 99% confidence level, so I'm going to change the 0.95 to 0.99. And when I hit calculate, I get the confidence interval 0.03764, 0.03764, 0.05445, and that p hat, that's the sample proportion, that's going to be the best estimate for the actual population proportion, 0.046049. That's the answer to the first question that they ask in the homework. Let's go back to the homework. So the best point estimate is that p hat that the calculator, it says it wants 3 decimal places, 0.046. Nice work. Oh, the margin of error. I wasn't ready for that. The margin of error is the distance from the endpoint to the middle of this confidence interval. So I'm going to have to calculate this. 0.05445 minus 0.03764. And that's the whole width of the interval. And then I'm going to take half of that distance to get the answer. So let me go back to the calculator. So on the calculator, let me get out of here. What I'm going to have to do is take the difference of those two numbers. I'll start with a parentheses, 0.05445, subtract off the lower bound, 0.03764, and the margin of error is half the width of that interval, so I'm going to divide by 2, and I get 0.008405, 0.008405. Let me go back to fill in the answer. How many point to 3 decimal places? 0.008, 0.008. Fantastic. And now the confidence interval are those endpoints. They want 3 decimal places to 3 decimal places. It was 0.038 if I round that off. 0.038, and 3 decimal places for the upper level was 0.054. 054. Check answer. Nice work. Which statement correctly interprets the confidence interval? Oh boy, let's see. It says one has 99% confidence that the interval actually does contain. I'm going to say it's 99% of the sample proportions. I think it's A, it might be D. Let's see. I was lucky.